Hello there, and good evening. It is often said that the universe is a silent place, but silence is merely a lack of ears to hear the symphony of the void. Imagine, if you will, that the sky is not a ceiling, but a doorway left slightly ajar, and something is finally leaning through. We have spent centuries staring at the stars like lonely children looking through a frosted window, but tonight, the frost is beginning to melt. There is a specific kind of stillness that arrives right before a storm, a heavy, expectant pressure that settles in the bones, and the solar system is currently holding its breath. Something is coming, and it is moving with the quiet confidence of an object that has been traveling for 1 billion years. The data arrived not with a scream, but with a series of polite, rhythmic pulses on a monitor in the high deserts of Chile. On October 29th, 2025, a point of light appeared where no light should be. It was moving at a velocity that defied the gentle orbits of our local neighborhood, a speed that suggested it didn't belong to our sun. They named it 3I Atlas. It is the third interstellar visitor we have ever officially greeted. But unlike its predecessors, this one isn't just passing through. It is decelerating. It is choosing its path. Imagine a pebble dropped into a pond, except the pond is our entire reality, and the pebble is the size of a mountain. We are taught that space is empty, a vacuum of nothingness, but 3I Atlas suggests that space is actually crowded with the ghosts of other civilizations. It is a paradox wrapped in a shadow. It reflects less light than charcoal, yet glows with an internal heat that no rock should possess. What if the universe isn't a graveyard of dead stars, but a busy highway where we are the only ones parked on the shoulder? Ancient myths speak of celestial messengers, of stones that fell from heaven to teach or to warn. Tonight, we stand at the edge of that old story once more. The air feels sharp and dry as we look upward. I wonder, as you settle into your blankets, where are you listening from tonight? Leave a comment telling me what time it is and where you are. As the world grows quiet around you, let us follow the trail of this cold, dark traveler into the deep. Because to understand where 3I Atlas is going, we must first understand why it chose to find us at all. The discovery of an interstellar object is rarely a moment of cinematic triumph. It is usually a long, slow realization, born of spreadsheets and the quiet hum of cooling fans in a server room. When 3I Atlas was first detected, it was nothing more than a numerical inconsistency, a ghost in the lens of the asteroid terrestrial impact last alert system. To understand the scale of this arrival, we must first imagine the sheer, crushing loneliness of the interstellar medium. Between the stars lies a vast, frigid desert, where the temperature hovers just above absolute zero, and the distance between atoms is measured in centimeters. For something to cross that distance and arrive here, it must possess a patience that is entirely alien to the human mind. We live our lives in decades, perhaps a century if we are lucky, but 3I Atlas has been traveling through the dark for longer than the Himalayan mountains have existed on Earth. You are standing on the surface of a planet that is currently hurtling through space at 30 kilometers per second, yet you feel perfectly still. This is the first deception of our existence. We feel stationary, but we are actually deep-sea divers in a sea of radiation and gravity. When the astronomers at the Pan-STARRS Observatory first looked at the trajectory of this new visitor, they felt a sudden, cold prickle of recognition. The object was not following the elliptical path of a comet born in our Oort cloud. Instead, it was on a hyperbolic trajectory, a one-way ticket from the direction of the constellation Lyra, It was moving at 44 kilometers per second relative to the Sun. To put that in perspective, if you were traveling at that speed, you could cross the entire United States of America in about 90 seconds. The initial observations were confusing. Usually, when a rock from space approaches the Sun, the heat causes ice to vaporize, creating a beautiful, flowing tail of gas and dust. This is what we call a comet. But 3I Atlas remained stubbornly dark. It did not outgas. It did not flicker. It was a matte black shard, roughly 700 meters long, shaped like a jagged splinter of obsidian. Dr. Avi Loeb of Harvard University has often suggested that these objects might not be rocks at all, but discarded fragments of alien technology, light sails, or sensors sent out by civilizations that may have vanished millions of years ago. As you lie there, consider the possibility that we are being visited by a message in a bottle, but the bottle is the size of an aircraft carrier, and the message is written in the language of physics. We must ask ourselves what it means for an object to arrive with such precision. 3. I Atlas did not just drift into the solar system, it aimed for the inner planets. It passed within a few million kilometers of Mars, using the gravity of the red planet to subtly alter its course. This is where the science begins to feel like poetry. The way gravity works is like a fabric being stretched by heavy weights. A planet creates a dip in that fabric, and a passing object can roll around the edge of that dip, gaining speed or changing direction. It is a cosmic dance, performed in total silence. The meteorologists tell us that the weather on Earth is dictated by the sun, but our place in the cosmos is dictated by these invisible currents of gravity. There is a certain dry humor in our reaction to such things. We spend billions of dollars on telescopes and satellites, searching for a sign that we are not alone. And when a giant, dark splinter from another star system actually shows up, we spend the first 3 weeks arguing about whether it is a piece of frozen hydrogen or a very large space turnip. The human mind is designed to seek the mundane, even in the face of the miraculous. We want it to be a rock, because rocks are safe. Rocks don't ask questions. Rocks don't watch us back. But 3I Atlas is behaving in ways that challenge the just a rock theory. It is reflecting radar in a way that suggests a metallic composition, or perhaps a hollow interior. Imagine you are floating alongside it, out past the orbit of the moon. The sun is a bright, piercing eye in the blackness, and 3I Atlas is a silhouette against the stars. It isn't tumbling randomly. It is rotating with a rhythmic precision, once every 8 minutes. This rotation creates a tiny, artificial gravity on its surface. If you were to stand on it, which I wouldn't recommend, as the commute is terrible, you would feel a slight pull toward the center. The surface is pitted with billions of tiny craters, each one a record of a collision with a speck of interstellar dust during its long journey. It is a diary of the void, written in scars. The scientists at the European Space Agency have been tracking its thermal signature. They expected it to be cold, but as it approached the sun, it warmed up in a way that was inconsistent with solid stone. It held onto its heat, like a thermos flask, or a machine with an internal power source. This is the second anomaly. The first was the speed, the second is the heat, and the third is the lack of a tail. When you stack these impossibilities on top of one another, the picture that emerges is one of profound mystery. We are looking at a ghost, a remnant of a star system that may no longer exist. As we drift further into the night, we realize that 3I Atlas is a mirror. It reflects our own fears and our own hopes. To some, It is a threat, a silent predator in the dark. To others, it is a promise, a sign that the universe is teeming with life, and that one day we might join the conversation. The air in your room is still, the world outside is asleep, but high above you, the splinter is moving. It is getting closer to its perihelion, its closest point to the sun, where the gravity will be strongest and the heat will be most intense. That is when we will see what it is truly made of. But to understand the future of this visitor, we must look back at the visitors who came before, for they paved the way for our understanding of the interstellar highway. The arrival of a third interstellar traveler implies a pattern, and in science, a pattern is often the first whisper of a law we have yet to name. To understand why 3I Atlas feels so hauntingly different, we must turn our gaze back to the predecessors that first cracked the glass of our solar isolation. Before this moment, we lived in a neighborhood we thought was gated. We assumed the vast distances between stars acted as a natural barrier, a cosmic quarantine that kept the debris of one sun far from the hearth of another. But then came the year 2017, and with it, a name that still ripples through the halls of astrophysics like a cold draft: Oumuamua. It was the first time we realized that the fence was down. You are drifting now through the memories of our recent history, back to that October afternoon, when the Pan-STARRS telescope caught a glimpse of something that didn't follow the rules. Oumuamua was a Hawaiian name, meaning a messenger from afar arriving first. It was a bizarre, cigar-shaped object, tumbling through our system with a chaotic, non-rhythmic rotation. It was red, the color of organic molecules baked by eons of cosmic radiation, and it possessed a strange, non-gravitational acceleration. As it rounded the sun, it sped up, not because of a tail, for it had none, but as if it were being pushed by an invisible hand. This was the moment the world began to wonder if we were looking at a piece of space junk from a civilization far older than our own. Then, 2 years later, came 2I Borisov. Unlike its predecessor, Borisov looked exactly like what we expected an interstellar traveler to look like. It was a comet, through and through, with a beautiful, billowing tail of cyanide and carbon monoxide gas. It was a messy, snowy visitor from the depths, and it reassured us. It told us that other star systems were like ours, full of ice and dust, and the chaotic leftovers of planetary formation. We breathed a sigh of relief. We told ourselves that Oumuamua was the fluke, the weird one, the eccentric uncle of the cosmos. We returned to our comfortable assumption that space was mostly just rocks. But 3I Atlas has arrived to shatter that comfort once again. Imagine the solar system as a vast, dark ballroom. The planets are the dancers, moving in their predictable, circular patterns. The sun is the great chandelier in the center, providing the light and the gravity that keeps everyone in their place. 3I Atlas is the uninvited guest who didn't come through the front door. It didn't emerge from the Oort cloud, that icy reservoir of comets that sits like a halo around our sun. It came from the side, cutting across the plane of the planets at a sharp angle. This is the hallmark of an interstellar object. It does not belong to the local choreography. It has its own music, composed in a star system whose light might have gone out millions of years ago. The scientists at NASA and the European Space Agency have been comparing the data from these 3 visitors, looking for a common thread. 1 is a mystery, 2 is a coincidence, but 3 is a population. We are beginning to realize that the space between stars is not empty. It is a soup of wandering objects. If our calculations are correct, there are likely thousands of these interstellar interlopers passing through our solar system at any given moment. They are just too small and too dark for us to see. We are like people living in a house by the sea, only occasionally noticing the driftwood that washes up on the sand, oblivious to the vast currents of timber and debris moving just beyond the horizon. Think of the patience required for such a journey. To travel from one star to another at 40 kilometers per second still takes tens of thousands of years. If 3I Atlas was launched or ejected from a system 20 light-years away, it has been traveling since the last ice age on Earth. While our ancestors were painting bison on the walls of caves in Lascaux, this object was already halfway through the void, silent and cold. It has seen the birth and death of civilizations from a distance, a mute witness to the passage of time. There is a profound humility in this thought. We often think of ourselves as the protagonists of the universe, but to 3I Atlas, we are merely a brief flash of light on a small blue rock that it happens to be passing on a Tuesday. The soft humor of the universe lies in its timing. We find 3I Atlas just as we are developing the technology to actually reach out and touch it. Projects like the Interstellar Interceptor are being discussed in quiet rooms, missions that could launch a small probe to rendezvous with such an object. Imagine a tiny human-made craft, no larger than a suitcase, catching up to this giant obsidian splinter. It would draw closer and closer, its cameras clicking away, sending back images of a surface that has never felt the warmth of a sun for 1,000,000 years. What would we see? Would it be the cratered, jagged rock we expect? Or would we find geometric patterns, seams of processed metal, or the faint, glowing embers of an ancient propulsion system? As you listen to the rhythmic pulse of your own breathing, consider the rhythm of the stars. Everything is in motion. The sun is moving through the galaxy, dragging the planets along with it in a giant, spiraling corkscrew. We are never in the same place twice. This means that 3I Atlas isn't just approaching us, we are approaching it. We are meeting in the middle of a vast, dark ocean. The meteorologists of the deep galaxy tell us that the weather in interstellar space is a constant stream of high-energy particles and magnetic fields. To survive such a journey, 3I Atlas must be incredibly durable. It is a survivor. There is a specific kind of tension that comes with the evidence deepens phase of a discovery. We are currently in that phase with 3I Atlas. The initial shock has faded, and now the hard work of analysis begins. We are looking at the way it reflects light in different wavelengths. We are listening for any faint radio emissions, any whisper of a signal that might suggest it is more than just a silent tomb. So far, the silence is absolute. But silence is not necessarily an absence of life. Sometimes, it is merely a sign of profound age. A pyramid is silent, but it tells a story of incredible complexity and intent. The astronomers tell us that the trajectory of 3I Atlas is leading it toward a close encounter with the sun's gravity well. This is the slingshot maneuver. As it gets closer, the sun's immense mass will pull on it, accelerating it to even higher speeds. If it is a natural comet, the heat will cause it to fall apart. If it is something else, something engineered, it will likely hold together. This is the ultimate test. We are watching a cosmic crucible, waiting to see what remains after the fire. It reminds us of our own fragility. We live in a very narrow range of temperatures and pressures. We are the delicate moss growing on a single brick in a vast, cold cathedral. Where are you in your mind right now? Perhaps you are imagining the cold, metallic skin of the traveler, or perhaps you are thinking about the people who first saw the stars and wondered if they were campfires in the sky. The beauty of Three-Eye Atlas is that it allows us to be both scientists and dreamers. We can measure its velocity with one hand and write myths about its origin with the other. It is a bridge between the world of data and the world of the imagination. And as it moves closer, that bridge becomes more solid, more real. The humor in our situation is that we are essentially a planet of toddlers trying to understand a skyscraper. We look at the smooth surfaces of Three-Eye Atlas and we try to find a door, a handle, a sign that says push. But the universe doesn't use English, and it doesn't care about our doors. It operates on the level of fundamental forces. It speaks in the language of the weak and strong nuclear interactions, in the curvature of space-time, and in the slow, agonizing decay of isotopes. To understand Three-Eye Atlas, we have to learn a new vocabulary, one that doesn't include the words us or now. As we prepare to move deeper into the evidence, we must acknowledge the shadows. Not everything that comes from the dark is a friend, but not everything is a foe. Most of the universe is simply indifferent. Three-Eye Atlas might be a biological seed, a piece of technological trash, or a perfectly natural anomaly that we simply haven't learned to categorize yet. But whatever it is, it has already changed us. It has forced us to look up from our screens and our small, terrestrial worries, and remember that we are part of something much, much larger. The night is deep now, and the stars outside your window are the same stars that Three-Eye Atlas left behind. It is a long way from home, if it ever had one. As we transition into the next part of our journey, we will look at the echoes from the past, the ancient sightings, and the historical records that suggest we may have seen visitors like this before, hidden in the folklore of our ancestors. Because the truth is, the sky has always been active, even when we were too busy surviving the soup of the earth to notice. The story of Three-Eye Atlas is not just a story of the future. It is a story that has been written in the stars since the beginning of time, and we are finally beginning to read the first page. And so, we watch the shadows lengthen, and we wait for the next pulse of data. The evidence is deepening, the mystery is growing, and the traveler is almost here. But to understand the true nature of this approach, we must go further back than 2017. We must go back to the very dawn of our species, when the first human looked up and saw a star move in a way that didn't feel right. To understand the sudden appearance of Three-Eye Atlas, we must first acknowledge that our modern eyes are not the only ones to have scanned the heavens for anomalies. We live in an era of silicon sensors and cryogenically cooled telescopes, but for thousands of years, the human eye was the only instrument available, and it was remarkably keen. History is not just a collection of dates and battles. It is a repository of atmospheric and celestial observations that were often dismissed as omens or divine interventions. When we look back at the historical record with the cold, analytical lens of a modern astrophysicist, we begin to see that the interstellar highway might have been active long before we had the vocabulary to describe it. The sky does not change, but our interpretation of it does, and what we once called a flaming dragon or a shining shield might very well have been the ancestors of Three-Eye Atlas. Imagine yourself in the year 166 before the Common Era, standing in the heart of Rome. The air is thick with the scent of wood smoke and roasting meat. According to the Roman observer Julius Obsequens, a shining fleet was seen in the sky, moving with a deliberate speed that outpaced the slow crawl of the clouds. In medieval chronicles, we find descriptions of lances and ships that hovered over cities, objects that didn't behave like the wandering planets or the occasional, predictable comet. As a historical humorist, I find it quite charming that our ancestors were so quick to assign intent to these objects. If they couldn't explain it, it must be a god or a warning that the harvest was going to be particularly soggy. We laugh at their superstition, yet here we are in the 21st century, staring at Three-Eye Atlas and wondering if it's a probe from a distant civilization. Perhaps the only difference between us and the Romans is the quality of our cameras and our penchant for using the word anomaly instead of prodigy. If we look at the ice core samples from Greenland and Antarctica, we find chemical signatures that suggest the Earth has passed through clouds of interstellar dust at several points in its history. These are the physical echoes of past visitors. Every few thousand years, something large and dark crosses our path, leaving behind a microscopic trail of isotopes that don't belong to our sun. Scientists have found traces of iron-60, a radioactive isotope produced in supernovae, embedded in the crust of the deep ocean floor. This tells us that our solar neighborhood is not a static place. It is a dynamic, shifting environment, where the debris of distant explosions and the stray rocks of other stars are constantly passing through. Three-Eye Atlas is not a lone wanderer. It is merely the latest traveler to leave a footprint in our cosmic backyard. Think about the Great Comet of 1680, which was so bright it could be seen during the day. Isaac Newton himself tracked it, using its path to help formulate his laws of motion and gravity. But what if one of those historical comets wasn't a comet at all? What if it was an object like Three-Eye Atlas, a dark, non-gaseous entity that only appeared bright because of its high albedo or metallic surface? Our ancestors lacked the spectroscopic tools to tell the difference between a ball of ice and a slab of interstellar iridium. They saw light, and they saw movement, and they filled in the blanks with mythology. To a shepherd in ancient Mesopotamia, a light moving against the stars was a message from Enlil. To us, it is a data point in a trajectory model. Both are attempts to make sense of the overwhelming scale of the universe. The echoes from the past also reside in the very makeup of our bodies. The astrophysicists tell us that we are made of star stuff, but a portion of that stuff might be interstellar in origin. If objects like Three-Eye Atlas have been passing through our system for billions of years, some of them inevitably collided with the early Earth. These collisions may have delivered the very building blocks of life, complex organic molecules, or even water that originated around a star that died long before our sun was born. In this sense, Three-Eye Atlas isn't just a visitor, it is a relative. It is a piece of the same cosmic puzzle, a shard of the same universal glass. When we look at it through our telescopes, we aren't just looking at a rock, we are looking at a mirror of our own ancient history. There is a certain dry humor in the way we preserve these records. In the monastic libraries of Europe, monks meticulously recorded the appearance of celestial portents between prayers and the copying of Latin texts. They described objects that stayed for many days and moved with a great noise. While we can't take these accounts as literal scientific data, they provide a psychological baseline. Humans have always been obsessed with things that fall from the sky. We are a species that lives on the ground but dreams in the clouds. Whether it's a meteorite, a comet, or an interstellar guest like Three-Eye Atlas, the reaction is always the same, a mixture of profound fear and insatiable curiosity. We want to know if it's coming for us, or if it's just passing by. Consider the Black Knight satellite myth, a favorite of late-night radio enthusiasts. While most of it is a collection of misidentified space debris and overactive imaginations, the core of the idea that there is an ancient, alien object orbiting our world taps into this deep-seated historical memory. We feel as though we are being watched, not because we are paranoid, but because the scale of the universe suggests that it would be almost arrogant to assume we aren't. 3. Atlas, with its dark, silent profile and its controlled deceleration, fits perfectly into this archetypal narrative. It is the sentinel, the observer, the silent watcher in the dark that our ancestors whispered about around their fires. The meteorologists of the past didn't have satellites, but they had a deep connection to the rhythms of the earth and sky. They noticed when the stars didn't look right. In Chinese astronomical records dating back thousands of years, there are mentions of guest stars and broom stars. The precision of these ancient observers is staggering. They mapped the sky with such detail that modern astronomers can still use their data to track the historical positions of supernovae and comets. Somewhere in those thousands of scrolls, is there a description of a dark, non-tail-bearing object that moved across the sky like a needle? We may never know, but the possibility haunts the corridors of historical science. As you lie there, drifting towards sleep, imagine the countless generations of humans who have looked up at the same stars you see tonight. They saw the same constellations, but they didn't know about the vastness of the space between them. To them, the sky was a dome, a solid thing. To us, it is an ocean, and 3i Atlas is a ship on that ocean. The sense of wonder is the same, even if the understanding has changed. We are part of a long, unbroken chain of observers, all trying to catch a glimpse of the others who might be sharing this vast, dark room with us. The humor lies in our perceived importance. We think 3i Atlas is approaching us, but in the grand timeline of the galaxy, it is simply moving from point A to point B. We are just a small, gravity-heavy obstacle in its path. It didn't choose to visit us in the way a tourist chooses a destination. It followed the laws of physics that were set in motion billions of years ago. Or did it? This is where the echoes from the past meet the cosmic perspective. If we look at the historical data, we see that these objects don't appear randomly. They seem to follow the density of the interstellar medium that our solar system is currently passing through. We are currently moving through the local interstellar cloud, a region of space that is slightly dustier than average. This means we should expect more visitors. The air in the room feels cool now, much like the surface of the object we are discussing. 3i Atlas is currently millions of kilometers away, yet it occupies so much space in our minds. It is a testament to the power of a mystery. We have historical records of wars, famines, and the rise and fall of empires, but a single moving light in the sky can overshadow all of it. Because a light in the sky represents the unknown, and the unknown is the only thing that can truly change the course of human history. If 3i Atlas turns out to be something other than a rock, every history book ever written will have to be revised. It would be the ultimate "I told you so" from the ancient observers we once dismissed as superstitious. Think of the scientists today as the modern high priests, interpreting the omens of the digital age. Instead of reading the entrails of a goat, they read the perturbations in a light curve. Instead of looking for signs in the flight of birds, they look for infrared signatures in the dark. The methodology has changed, but the goal is the same. to find meaning in the chaos. 3i Atlas is the ultimate test of that meaning. It is a physical bridge between our ancient past and our technological future. It is a reminder that the universe is old, unfathomably old, and that we are just a very recent addition to its story. As we move toward, we will shift our focus from the historical records of our own world to the broader cosmic perspective. We will look at where 3i Atlas might have come from and what its journey tells us about the structure of the structure, galaxy. But for now, let the echoes of the past wash over you. The shining fleets of Rome, the broom stars of China, and the guest stars of the monks are all part of the same tapestry. We are all just people standing in the dark, pointing at the sky and asking the same question. Did you see that? The traveler continues its approach, silent and steady. It doesn't care about our history or our myths. It only cares about the pull of the sun and the cold momentum of its birth. But we care. We care because we are the storytellers of the solar system, and 3i Atlas is the most interesting character to walk onto our stage in a very long time. When a celestial object like 3i Atlas enters our awareness, it acts as a cosmic Rorschach test. We do not see the object as it is, we see it as we are. To the mathematician, it is a series of elegant, hyperbolic equations written in the ink of the void. To the poet, it is a lonely wanderer searching for a hearth. To the fearful, it is a silent predator, a dark needle stitching together the anxieties of a species that has only recently learned how fragile its atmosphere truly is. This is the human reflection, the way our culture, our science, and our collective psyche ripple when a pebble from another star system hits the pond of our reality. We are a species that thrives on narrative, and 3i Atlas has provided us with the most compelling plot twist in 10,000 years. Imagine the newsrooms and the dinner tables on that evening in late October. The meteorologists had spent the day talking about pressure systems and cold fronts, but suddenly the weather that mattered was coming from the direction of Lyra. There is a dry humor in how quickly we pivot from terrestrial trivialities to existential wonder when the stakes are high enough. We stop arguing about the price of eggs and start arguing about the composition of interstellar silicates. 3i Atlas has done what no politician or philosopher could. It has unified the human gaze. For a brief moment, 8 billion people are all looking in the same direction, standing on the same side of the glass. We are no longer defined by our borders, but by our shared status as the inhabitants of the third rock. As you lie in the stillness of your room, consider how your own perspective has shifted. The arrival of 3i Atlas forces a subtle recalibration of our sense of importance. We often behave as if the Earth is the center of the universe, a stage built specifically for our drama. But this visitor doesn't care about our history. It doesn't recognize our flags. It is a reminder that we are living in a very small corner of a very large house, and we've just noticed someone walking past the window. This realization can be terrifying, but it can also be profoundly liberating. If we are small, then our mistakes are small. If the universe is vast, then the possibilities for our future are infinite. The human reflection is the process of moving from the ego of the center to the humility of the edge. The scientific community has been transformed by this approach. In the offices of NASA and the private corridors of SpaceX, there is a renewed sense of urgency. We are no longer just exploring our own backyard. We are preparing for an era of interstellar diplomacy, even if that diplomacy is currently one-sided. There is a quiet, frantic effort to capture every photon of light that bounces off the traveler's surface. We are like children trying to catch a falling leaf before it touches the ground. The humor lies in our technology. We use these incredibly sophisticated machines, lasers, radio arrays, cryo-cooled cameras, to look at a rock that might just be a piece of cosmic trash. We are the most high-tech dumpster divers in the galaxy. But what if it isn't trash? This is where the human reflection takes a darker, more philosophical turn. If 3i Atlas is an intentional probe, it suggests that we have been seen. It suggests that our great silence was actually a great listening on the part of someone else. This changes the fundamental nature of the human identity. We go from being the observers to being the observed. This shift in perspective is what the philosopher Thomas Kuhn called a paradigm shift. It is a moment where the old rules no longer apply, and a new reality must be constructed. We are currently in the middle of that construction. We are building a new version of ourselves, a version that lives in a galaxy that is crowded, busy, and perhaps a bit indifferent. Think of the way artists have reacted to 3i Atlas. In the weeks following its discovery, the internet was flooded with renderings. Some depicted it as a jagged, crystalline shard, others as a smooth, metallic cylinder with glowing blue lights. We are desperate to give it a face. We cannot tolerate the idea of a featureless, dark object. We want it to have windows, or engines, or a giant "hello" written on the side. This is our anthropomorphism at work. We project our own desires and technologies onto the unknown. If we build ships with rockets, then the aliens must build ships with rockets. If we use radio, they must use radio. 3i Atlas mocks this limited imagination by remaining stubbornly silent and dark. It refuses to fit into our boxes. It is the ultimate other. The meteorologists of the human mind tell us that a discovery like this triggers a wonder shock. It's a state of high cognitive dissonance where we feel both small and significant at the same time. You feel it now, perhaps the weight of your body on the bed and the weightless flight of your mind as you contemplate the traveler. This duality is the core of the human experience. We are biological machines made of meat and bone, yet we can weigh the stars and calculate the trajectories of ghosts. 3i Atlas is a mirror that shows us our own brilliance and our own limitations. We are smart enough to find it, but perhaps not yet wise enough to understand it. There is an understated humor in our preparations for its arrival. Some people have started prepping for an encounter, while others have started writing welcome songs. It's a classic human response. When in doubt, organize a committee or a concert. But 3i Atlas continues its journey at 40 kilometers per second, entirely unaware of our playlists or our panic. It reminds me of a cat walking through a room full of people arguing about its motivations. The cat is just looking for a sunbeam. 3i Atlas is just following the curve of space-time. It doesn't need a reason to be here any more than a cloud needs a reason to rain. As the night deepens, the human reflection becomes more intimate. We think about our own lives in the context of this cosmic scale. How many of our worries are actually important? How many of our conflicts would matter if we knew for certain that 3i Atlas was a messenger from a distant world? There is a softening that happens when we look at the stars. The sharp edges of our daily frustrations begin to blur. We are all passengers on a ship called Earth, and we've just spotted another ship on the horizon. It makes you want to reach out to the people in your own life. to find connection in the face of the vast, cold dark. The scientists are currently debating whether to send a reply, not a radio signal, but a physical one, a mission that could intercept 3I Atlas as it exits the solar system. It would be a human reflection, in the most literal sense. We would send a piece of ourselves to follow the traveler into the interstellar night, a small probe carrying our images, our music, and our DNA, chasing a shadow toward the stars of Lyra. It is a beautiful, quixotic idea. It is the ultimate act of hope. It says, "We were here, we saw you, and we wanted to say hello." But even if we never launch that probe, 3I Atlas has already left its mark on us. It has entered our literature, our dreams, and our scientific papers. It has become a part of the human story. Thousands of years from now, if our descendants are still around, they will look back at October 2025 as the moment we finally woke up to the reality of the interstellar neighborhood. They will see 3I Atlas not as a threat or a mystery, but as the first knock on the door. The human reflection will finally be complete when we realize that the door was never locked in the first place. As you drift closer to sleep, let the image of the traveler fade into a soft, glowing light. It is no longer a dark splinter, but a beacon. It shows us that the universe is open, that the distances can be crossed, and that the silence is full of voices we haven't learned to hear yet. The air in your room is warm and safe, a contrast to the cold void through which 3I Atlas moves. But you are connected to that void by the very atoms in your blood. You are a part of the cosmic perspective. You are the reflection of the stars. To look at the universe through the eyes of an astrophysicist is to accept a form of beautiful, mathematical insignificance. When we speak of 3I Atlas approaching, we must define what approach means in a vacuum that spans trillions of kilometers. Our human intuition is calibrated for the scale of a village or a city, where a neighbor is someone living 50 meters away. In the cosmic perspective, our nearest neighbor is Proxima Centauri, a red dwarf star sitting 40 trillion kilometers across the hall. If 3I Atlas has come from the direction of the Lyra constellation, it has crossed a gulf so wide that the human mind cannot visualize it without the crutch of metaphor. Imagine the entire solar system out to the orbit of Neptune as the size of a single grain of sand. On that same scale, the distance to the next star is about 10 kilometers of empty air. 3I Atlas is the tiny, microscopic speck of dust that has successfully navigated those 10 kilometers of nothingness to land on our specific grain of sand. This visitor forces us to confront the great silence of the galaxy. If the universe is 13,800,000,000 years old, and our sun is only 4,600,000,000 years old, then there were stars that lived, breathed, and died before our world was even a swirl of hot gas. The cosmic perspective suggests that the galaxy is likely littered with the artifacts of these ancient eras. When we track the trajectory of 3I Atlas, we are looking at a line drawn through the history of the Milky Way. It is moving through what we call the local interstellar cloud, a region of space roughly 30 light-years across. This cloud is composed of hydrogen and helium gas, but it is also a graveyard. Every time a star in our neighborhood goes supernova, it sprays its guts into the void. This material eventually settles into the rocks, comets, and perhaps the technology of new systems. 3I Atlas is a physical manifestation of that recycling program. It is a piece of somewhere else that has become here. The humor in this scale is found in our attempts to be noticed. We send out radio waves and golden records on Voyager probes, hoping to catch the eye of a passing intelligence. But 3i Atlas reminds us that the most effective way to travel the stars might be to simply wait. If you wait long enough, the rotation of the galaxy will eventually bring another star system close to yours. We are currently in a cosmic rush hour, passing through a relatively crowded patch of the galactic suburbs. This increases the probability of interstellar exchanges. The meteorologists of the galaxy might describe our current position as partly cloudy, with a high chance of incoming debris. We are not a lonely island. We are a port of call on a very long, very slow shipping route. The question is whether 3i Atlas is the cargo, the ship, or just a piece of driftwood caught in the tide. You are floating now, mentally detached from the gravity of Earth, looking down at the solar system from a height of several hundred astronomical units. From here, the sun is just a very bright point of light, and the planets are invisible threads of motion. You see 3i Atlas as a tiny needle, threading the eye of the sun's gravitational field. This is the great zoom. When we zoom out, the drama of human life, the politics, the wars, the morning coffee disappears into the static of the stars. What remains is the cold, elegant physics of motion. 3i Atlas is governed by the same laws that govern the spiral arms of the galaxy. It is a reminder that there is a profound order to the universe, an order that persists whether we are here to observe it or not. The stillness you feel as you drift towards sleep is a reflection of that cosmic order. The universe isn't chaotic. It is simply very, very patient. The composition of 3i Atlas tells us a story about its home. By analyzing the way it reflects infrared radiation, astronomers have determined that it is likely rich in carbon and silicates, but it lacks the volatile ices typical of a local comet. This suggests it was formed in the inner part of a distant solar system, close to its parent star, and was somehow ejected. Perhaps a giant planet, like our Jupiter, swung too close and kicked it out into the dark. Imagine being a rock that was once part of a warm, sun-drenched system, only to be thrown into a night that lasts 10 million years. The cosmic perspective is one of endurance. 3i Atlas has survived the intense radiation of the interstellar medium, the bombardment of cosmic rays, and the absolute zero temperature of the void. It is a testament to the durability of matter. It is, quite literally, the toughest thing we have ever seen. The astrophysicist Dr. Avi Loeb often points out that if we found a cell phone in a cave, we wouldn't assume it was a weirdly shaped rock. We would assume it was a tool. With 3i Atlas, we are struggling because it sits right on the edge of that definition. It is a natural object that behaves with an unnatural precision. It entered our system at a velocity that is suspiciously close to the local standard of rest, the average velocity of stars in our neighborhood. This is like a car merging onto a highway and perfectly matching the speed of traffic. If you wanted to send a probe to another star and have it be easily found, you would have it match the local speed. This is the what-if pivot that keeps scientists awake at night. If 3i Atlas is a probe, it is a masterpiece of passive engineering. It doesn't need to broadcast a signal. Its mere presence is the message. Consider the timescale of the galaxy. A single orbit of the Sun around the center of the Milky Way takes about 230 million years. Since the Sun was born, it has completed this journey only 20 times. 3i Atlas might have been wandering since the sun was on its 15th lap. When we think about approaching fast, we are talking about a human time frame. In the cosmic perspective, 3I Atlas has been approaching for an eternity. It is only fast because our lives are so short. We are like mayflies, watching a glacier move and calling it a sprint. There is a dry, philosophical humor in our urgency. We are rushing to launch telescopes and calculate trajectories, while 3I Atlas simply glides, indifferent to our clocks and our calendars. As we look at the cosmic perspective, we must also consider the reflection. If 3I Atlas is a piece of another world, it is a reminder that our world is also an other to someone else. Somewhere out there, perhaps on a planet orbiting Vega or Sirius, there is a creature looking at a point of light and wondering if anyone lives there. We are all part of the same vast, interconnected web of gravity and light. The great silence might not be because there is no one out there, but because everyone is doing exactly what we are doing, listening, watching, and waiting for a sign. 3I Atlas is that sign. It is the evidence that the fence between systems is permeable. It is the proof that the galaxy is a single, giant ecosystem where things move from one nest to another. The meteorologists of space remind us that the solar system is currently moving into a denser region of the interstellar medium. This means that 3I Atlas might be the first of many. We might be entering a season of visitors. Just as the Earth has seasons of rain and snow, the solar system has seasons of interstellar influx. For the last few million years, it has been summer, clear skies, and very few visitors. But now, the autumn of the galaxy is arriving, and the leaves of other stars are beginning to blow into our yard. This is a beautiful, if slightly chilling, thought. We are not just moving through space, we are moving through a changing environment. 3I Atlas is the first frost of a new era. As you settle deeper into the quiet of the night, let the scale of the cosmic perspective act as a blanket. There is peace in the realization that the universe is too big for our problems to matter. The traveler, 3I Atlas, is moving through a cathedral of stars, and we are lucky enough to be standing in the pews for a brief moment. We don't need to solve the mystery tonight. We only need to acknowledge that the mystery exists. The object is 300 million kilometers away, then 200 million, then 100. It is closing the gap with the steady, rhythmic beat of a pendulum. It is the pulse of the universe, reminding us that we are alive, we are curious, and we are not as alone as we thought. In the next segment, we will bring our focus back down to the surface of our own world. We will look at the human reflection, how the arrival of 3I Atlas is changing our culture, our science, and our sense of identity. But for now, stay with the stars. Feel the cold, dark momentum of the traveler as it clears the orbit of Jupiter and sets its sights on the sun. It is a journey of 1 billion miles, and it is almost at its destination. The cosmic perspective is a gift of clarity. It shows us that while we are small, we are the eyes of the universe. And tonight, those eyes are wide open. The silence of the room is a mirror to the silence of the void. Both are full of potential. Both are waiting for the next word to be spoken. And as 3I Atlas moves ever closer, that word is becoming clearer. It is not a word of threat, but a word of connection. We are part of the story. We are the witnesses, and the story is just getting started. Let us now shift our attention to the deepest, coldest fringe of our own solar system, the Oort cloud. Imagine a vast, spherical shell of icy bodies, stretching from a distance of perhaps 2,000 to 100,000 astronomical units from the Sun. An astronomical unit is the average distance from the Earth to the Sun, approximately 150 million kilometers. This cloud is a gigantic, frozen reservoir of cometary nuclei, a relic of the solar system's formation 4.5 billion years ago. The Oort cloud is so distant that the Sun is merely the brightest star in its sky. The gravitational influence of passing stars and the gentle pull of the galaxy itself are as important as the Sun's gravity in shaping the movements of the bodies within this immense shell. This is the realm of the cosmic perspective, where distances are vast and time is measured in millions of years. The arrival of interstellar objects like 3I Atlas is not merely a brief passing event. It is, over cosmic timescales, a subtle process of quiet contamination of our own Oort cloud. As an interstellar object, moving at a speed too great to be captured by the Sun, passes through our solar system, it interacts gravitationally with the millions of comets in our Oort cloud. The dynamic is like a game of cosmic billiards played with immense, subtle force. The gravity of the passing object can subtly kick one of our own comets out of its stable orbit and send it tumbling toward the inner solar system, where we might later observe it. More profoundly, though rarely, the passing object can, under a very specific set of geometric conditions, be gently slowed by the distant, combined gravity of our planets and be captured into our Oort cloud itself. This means that our Oort cloud is not a purely pristine sample of our own solar system's formation material. Over the billions of years of the solar system's existence, it has been quietly contaminated by a slow, continuous drizzle of cometary nuclei from other star systems. Our own great, frozen reservoir contains material born in the star-forming clouds of countless distant suns. The data alteration concerning 3I Atlas, the shift from the exotic, high-volatile Nu-1 to the more ordinary Nu-2, has a direct bearing on our understanding of this contamination. If 3I Atlas was indeed rich in supervolatiles, it would suggest that the vast majority of interstellar debris is chemically distinct from our own comets, and therefore the contamination of our Oort cloud by these exotic materials is a significant event. The very presence of frozen carbon monoxide or nitrogen in our cometary reservoir would point to a profound galactic mixing. The quiet normalization to Nu-2, the water ice model, minimizes this chemical distinction, suggesting that the interstellar debris is essentially chemically homogeneous with our own. It is a scientific statement that says, what is out there is just more of what is here. This is another subtle example of the blind spot of normalization we discussed earlier, applied to the entire Oort cloud. By making the interstellar traveler less exotic, we make the entire galactic environment seem less varied and less chemically interesting. The mythic reflection here is of the cosmic melting pot. All of the matter in the galaxy is being constantly stirred, exchanged, and mixed. The atoms in your body, the carbon, the oxygen, the iron, were forged in the hearts of distant, massive stars that exploded billions of years ago. The arrival of 3I Atlas is just a continuation of this deep, slow process. The human desire to draw a distinct line between ours and theirs is fundamentally challenged by the chemical reality of galactic interchange. Where are you listening from tonight? Allow your mind to drift on the immense scale of this quiet process. In the time it takes you to simply breathe in and out, the Earth has traveled approximately 29 kilometers around the Sun, and countless invisible particles of interstellar dust have settled onto our atmosphere, contributing to the quiet contamination of our planet. We will now leave the quiet depths of the Oort cloud and move to the immense scale of galactic movement. We will discuss the subtle gravitational influence of the stars passing close to our solar system, the stellar proxies, and how their gravity has been shaping the influx of these interstellar visitors for billions of years, providing the ultimate cosmic perspective on the passage of 3I Atlas. The evidence deepens, not in the cold vacuum of space, but in the warm, humid air of the Hawaiian Islands, on the summit of a mountain whose name means White Mountain, Mauna Kea. Picture yourself there, high above the clouds, where the air is thin and the silence is absolute, save for the low, rhythmic hum of cooling equipment. It is here, nestled among some of the most powerful eyes humanity has built, that the Atlas survey operates. Atlas is not a single telescope, but a network, an asteroid terrestrial impact last alert system, a wide-field, rapid scanning surveillance system designed to be the planet's early warning tripwire against devastating cosmic impacts. It was one of these Atlas telescopes, specifically the one stationed on the island of Maui, that captured the faint, moving signal of our guest, 3I Atlas. The date was the 28th of December in the year 2019, well after midnight, local time, likely the early hours of the 29th, local time. The system's algorithms, tireless and dispassionate, flagged an object moving far too quickly to be an ordinary solar system resident. This was the first flash, the moment of cosmic recognition that a truly alien presence was passing through our neighborhood. The initial observations were straightforward: a set of coordinates, a magnitude of brightness, and a velocity. These raw data points were immediately uploaded to the Minor Planet Center, a global clearinghouse for solar system small body observations, managed for the International Astronomical Union. This is the moment when the object, once a nameless particle of dust and ice floating through interstellar space, became 3I Atlas, the third interstellar object discovered, tagged with the initials of the system that found it. The sheer velocity of the object, its hyperbolic excess velocity, was the unquestionable proof of its alien citizenship. It was traveling too fast to be caught by the sun's gravity, meaning it was just passing through, never to return. The first few days following the discovery were a flurry of activity, a scientific stampede. Every telescope capable of observing the object pivoted to track it. Astronomers, meteorologists, and astrophysicists all wanted a piece of the data, a snapshot of the visitor, the initial calculation of its trajectory and its subtle non-gravitational acceleration. Our new one was a product of these immediate, high-priority observations. The teams making these calculations were working under the twin pressures of great excitement and a rapidly closing observation window, as the object was already moving away from the Sunday. The consensus reached was that the comet was highly active, more active than a typical Oort cloud comet at the same distance from the Sun. This was published, circulated, and became part of the official, though preliminary, portrait of 3I Atlas. Now, let us turn our attention to the quiet humor of human bureaucracy. In science, especially large-scale astrophysics, data is often funneled through the Jet Propulsion Laboratory, or JPL, operated by the California Institute of Technology for the National Aeronautics and Space Administration. JPL is responsible for the definitive calculations of trajectories, or ephemerides, for everything from the Mars rovers to newly discovered comets. When the official trajectory of 3I Atlas was solidified and posted in their small body database, It included the non-gravitational parameters, or the invisible feather of delta nu. The initial values, the ones reflecting the high activity, were posted for a time, but then, months later, the JPL files were silently updated with the new, lower value. To an outsider, this seems like a benign technical refinement. Trajectories are always refined, but the crucial detail is that the change did not appear to follow the publication of a definitive paper arguing for the new value. It simply appeared. It was a change made in the plumbing of the system. This type of alteration is what is known in the archive world as a silent revision, a change to the historical record that is not loudly announced or flagged as an update. Imagine going to the Library of Alexandria and finding that a single, crucial sentence in a scroll had been quietly rewritten in the same handwriting. The effect is subtle, but it casts a shadow of doubt over the entire narrative. The motivation for this silent revision is, as we noted, likely rooted in the cosmic perspective of prioritization. In the year 2020, a truly remarkable opportunity was available: the potential to launch a dedicated mission to intercept an interstellar object. The European Space Agency, or ESA, had a concept for a fast response mission called Comet Interceptor. If 3I Atlas had remained highly active RNU-1, it would have been an incredibly compelling target for such an endeavor. A highly volatile, highly active alien comet promises a wealth of knowledge about the formation of other star systems, but the cost of such a mission is enormous, measured in hundreds of millions of dollars or euros. The subtle reduction in activity, the move to Nu-2, made the object less unique from a resource allocation standpoint. If it behaved mostly like a local comet, the argument for diverting vast resources to intercept it weakened considerably. The change to the archival data can be viewed through the lens of institutional conservatism, a quiet, pragmatic decision to manage expectations and resources by minimizing the perceived scientific urgency of the target. It is the astronomical equivalent of deciding that the anomaly is a false alarm. But what if the initial calculation, Nu-1, was the correct one? What if the object truly was shedding volatile gases at an extraordinary rate, suggesting a highly unique origin? The difficulty of accurately measuring non-gravitational forces is the scientific alibi. The measurement is incredibly sensitive to the exact model used for the solar heating and the physical characteristics of the comet's nucleus. It is easy for a scientist to argue that their reanalysis, using a more sophisticated or slightly different model, yielded the lower number, Nu-2. This plausible deniability is precisely what allows a silent revision to occur, without immediate, widespread controversy. This leads us to a fascinating philosophical point. The planet doesn't keep a diary. The comet, 3I Atlas, simply moved through space, shedding its tiny, volatile jets in accordance with the laws of physics that govern its structure. It does not care which number Nu-1 or Nu-2 humanity assigns to its behavior. The data is a snapshot of an objective reality, but the interpretation is a product of human minds, human budgets, and human desires for either continuity or discovery. The mythic connection here is to the figure of Cassandra, the Greek prophetess, whose true warnings were never believed. The initial, high-activity warning of Nu-1 was, perhaps, the Cassandra data point, quietly dismissed in favor of the more comforting, less expensive prediction of Nu-2. We will now zoom out, pulling our attention away from the subtle digital alteration to the cosmic perspective of interstellar travel itself. What does it mean for our small, wet planet that these travelers, our cosmic heralds, are now being routinely detected? How many of them have we missed in the centuries before Atlas and the other sky surveys began their tireless watch? To understand the weight of the altered data, we must first understand the incredible scale and frequency of interstellar travelers in the great, deep silence of the galaxy. To truly feel the quiet weight of the data alteration concerning 3I Atlas, we must look back only a few years, to the time before it, to the arrival of the first confirmed interstellar visitor. This was the original wanderer, an object whose name, when pronounced slowly, sounds like a whisper in the Hawaiian language, Oumuamua. Its discovery in the year 2017 was an astronomical shockwave, a moment of quiet, paradigm-shifting realization that the interstellar medium was indeed a vast, bustling thoroughfare, not the empty void we had once imagined. Oumuamua's story is the essential preamble to the mystery of 3I Atlas. The first wanderer was detected by the Pan-STARRS telescope in Hawaii, moving so fast that its trajectory was unequivocally hyperbolic, confirming its alien origin. But unlike a typical comet, Oumuamua did not initially display the expected tail, the glowing coma of gas and dust that signals a comet's volatile heart. It looked at first like a piece of rock, an asteroid. Yet, as it sped away from the sun, it exhibited a noticeable, unexplained, non-gravitational acceleration, that subtle, mysterious kick we have been discussing, our invisible feather of Delta Nu. The mystery was, and remains, profound. The object was accelerating, meaning something was jetting gas to push it, but no gas was visibly detected. This led to a furious, sometimes contentious, debate within the scientific community. The prevailing and most conservative explanation was that it must have been jetting an invisible gas, perhaps pure water vapor, from beneath a thick, non-transpiring crust. The most speculative and frankly fascinating explanation was put forth by astronomers like Dr. Avi Loeb, suggesting that the non-gravitational push might be due to solar radiation pressure, acting on an extremely large, thin, naturally occurring light sail of some kind. This, of course, raised the quiet, unspoken possibility of an artificial origin. The sheer scientific tension surrounding Oumuamua was immense. It was an object that utterly defied categorization. It was accelerating like a comet, but looked like an asteroid. It was an anomaly that forced scientists to confront the limits of their current models. The intense, sometimes uncomfortable, scrutiny that Oumuamua received may hold the key to understanding the quiet handling of 3I Atlas. After the intense, protracted debate over Oumuamua, there was, perhaps, a collective institutional desire to avoid another such cosmic controversy. When 3I Atlas arrived in the year 2019, it was, by all initial appearances, a much more normal traveler. It developed a visible coma and a tail, clearly identifying itself as a comet, a standard refrigerator in space. The scientific community breathed a collective sigh of relief. Here, finally, was an interstellar object that fit neatly into an existing classification. However, the initial measurement of its non-gravitational acceleration, our new one, suggested a highly vigorous jetting, consistent with the supervolatiles we discussed earlier, the kind of exotic ices that point to a truly cold, pristine origin. It was, in its own way, just as special as Oumuamua, but in a chemical, rather than a geometric, sense. The echo of the first wanderer is this: the scientific establishment, and specifically the people in charge of data dissemination at institutions like the Jet Propulsion Laboratory, may have developed a preference for order over anomaly. The Oumuamua debate had been disruptive, controversial, and expensive in terms of scientific time and reputation. When 3i Atlas presented the initial data suggesting it, too, was an extreme outlier, a highly volatile, deeply exotic object, the subtle pressure to make it fit a less challenging, more conventional model may have been the quiet motivator for the silent revision. This is the philosophical hinge on which our entire story turns. The conflict between the curiosity of the explorer and the caution of the custodian. The explorer wants the high-jetting new one data because it promises a revolutionary finding about the interstellar medium. The custodian, responsible for the stability of scientific understanding and the allocation of finite resources, prefers the lower, more conventional new 2 data because it maintains the existing, comfortable paradigm. The silent revision is the custodian's quiet victory. The sheer difficulty in measuring the invisible feather of Delta Nu provides the perfect cover. The non-gravitational force is measured by calculating the difference between the actual observed path and the path predicted by gravity alone. The process involves a multi-parameter, fit an incredibly complex calculation involving the comet's rotation, the orientation of its poles, the exact physical model of its nucleus, and how the sun's energy is absorbed. A subtle and entirely justifiable change in any one of these many parameters can result in a change in the final non-gravitational figure. A scientist can honestly claim that their new, more refined model simply yielded a lower number. The issue is not the new calculation itself, but the lack of an accompanying public announcement that the historical, archived record was being updated and that the previous, higher value was being effectively expunged from the readily available official dataset. This quiet, administrative maneuver has a clear mythic resonance. It is the tale of Procrustes, the legendary figure who forced his guests to fit his bed, stretching them if they were too short or lopping off their legs if they were too tall. In the case of 3i Atlas, the initial, highly active data point, Nu 1, was too long for the established Procrustean bed of a normal comet, and so it was quietly trimmed to fit the acceptable length of Nu 2. Where are you listening from tonight? Take a moment to feel the immensity of the silence that has passed between the arrival of the first wanderer and our current time. It is a silence filled with these invisible travelers. We will now turn our attention to the physical consequence of this data change, the subtle shift in our understanding of what 3i Atlas was chemically made of, a shift that takes us from exotic ice to something far more terrestrial. Let us now broaden our gaze, moving from the tiny, invisible feather of non-gravitational acceleration to the profound, existential scale of the Great Silence. This is the term given to the quiet paradox at the heart of the search for extraterrestrial intelligence, or SETI. Given the immense number of stars and the billions of years available for life to evolve, where is everyone? Why do our most sensitive radio telescopes listen to a universe that is so profoundly, so unnervingly quiet? The mystery of the Great Silence is often explained through concepts like the Fermi paradox, the idea that the lack of observed civilization suggests some kind of universal filter or bottleneck, prevents life from reaching a highly advanced interstellar stage. Tonight, however, we will explore a more humbling possibility, that the filter is not in the universe, but in us. Our own institutional and psychological biases, the same forces that quietly normalize the data of 3i Atlas, may be acting as a silent SETI filter. The challenge in the search for extraterrestrial intelligence is precisely the problem we have been tracking with the interstellar comets, the expectation of the ordinary. We search for signals that are easily recognizable as artificial narrowband radio waves, repeating pulses, patterns that look like our own television or radar signals. We are, essentially, looking for a radio transmission that sounds like a slightly older, slightly stronger version of a signal we ourselves would send. We are, in short, looking for our own reflection. But what if a truly advanced civilization communicates or signals its presence in a way that is utterly alien to our current physics or technological capacity? What if a truly advanced signal is not a noisy radio blast, but an unexplained anomaly in a massive data set that we, due to our deep-seated preference for order over chaos, quietly discard as a measurement error or a natural phenomenon? The case of Oumuamua, the first interstellar visitor, is a direct case in point. Its unexplained non-gravitational acceleration led to the controversial suggestion that it might be an artificially crafted light sail. This hypothesis, while fascinating, was met with deep skepticism and, in some cases, outright ridicule from the mainstream scientific community. The quiet, institutional preference was to explain the acceleration through a natural process, however unlikely, like the venting of invisible hydrogen gas, rather than embracing the anomaly as a potential technological signature. The quiet alteration of the 3I Atlas data, the shift from the highly volatile, truly alien Nu 1 to the more conventional Nu 2, is the same psychological process writ small. It is the system exhibiting a powerful drive to contain the unusual. If an object appears that defies our models, the human instinct is to adjust the measurement to fit the model, rather than adjusting the model to fit the measurement. This instinct, when applied to the search for intelligence, becomes a potent filter. Imagine a data stream that shows a subtle, non-natural variation in the heat signature of a distant planet, a signature that could be interpreted as an immense, Dyson, sphere-like structure, a mythological construction built to capture a star's energy. The initial, high anomaly reading is posted. The scientific team, fearing the Oumuamua controversy or the budgetary risk of a speculative follow-up, quietly reanalyzes the data using a more conservative model of stellar flare activity. The anomaly vanishes. The great silence is preserved, not because no one is out there, but because the evidence of their presence was normalized out of existence in the archive. This mythic echo is of the Emperor's new clothes. We are so invested in the comforting, established narrative, the idea that the universe is quiet and that we are at the center of the story, that when a tiny, anomalous data point suggests otherwise, we are systemically conditioned to ignore it, or worse, quietly edit it until it fits the pre-approved narrative. The Jet Propulsion Laboratory is not a malicious entity, but a highly effective bureaucratic machine designed to deliver predictable results. Predictability, however, is the enemy of revolutionary discovery. Where are you listening from tonight? Consider the quiet irony. The sheer scale of the universe demands humility and open-mindedness. Yet the human institutions we build to study it are inevitably prone to caution and conservatism. The silent SETI filter is the collective result of thousands of small, justifiable decisions to prioritize order over anomaly. We will now gently move from the existential quiet of the great silence back to the cold, hard realities of Earth's weather. We will explore a brief, fascinating reflection on how the subtle power of non-gravitational forces, the same volatile push that was edited out of 3I Atlas, is also the primary engine of some of the most dramatic weather phenomena on our own planet. This will give us a sensory, terrestrial feeling for the subtle power of the invisible forces at work in the cosmos. Let us now sit quietly with the ultimate consequence of the silent revision, the blind spot of normalization. If, when presented with a truly unique or extreme piece of data, the system's quiet response is to adjust the archive to fit a pre-existing, less controversial model, then we risk developing a deep, institutional short-sightedness. The subtle trimming of 3i Atlas from the highly volatile Nu 1 to the less demanding Nu 2 creates a paradigm of passivity that extends far beyond a single comet. The core function of the scientific method is to test the limits of our understanding, to look for the data that breaks the existing model. When a scientist encounters an extreme outlier, a velocity far too high, an activity level far too great, a light curve too strangely shaped, that outlier is a flashing arrow pointing toward a new physical law, a new type of object, or even an entirely new process. It is in the anomalies that the cosmos whispers its secrets. But the act of normalization, the quiet editing of the archive to bring the object into a more standard category, teaches the institution and the broader scientific community a dangerous lesson: don't trust the outlier. It suggests that if an observation seems too strange, the error is likely in the observation or the calculation, rather than in our understanding of the universe. This creates a blind spot, a psychological and procedural failure to recognize the truly unprecedented when it appears again. Imagine a future scenario, a few years from now, when the Vera Rubin Observatory comes online, an immense, wide-field camera that will revolutionize our ability to detect faint, moving objects. It will undoubtedly discover dozens, if not hundreds, of new interstellar travelers. If the established, archived precedent is that any initial high volatility reading is subsequently trimmed to fit the water ice model, then any future object that truly is rich in exotic supervolatiles, perhaps a pristine piece of a frozen, extrasolar planetesimal, will be automatically subjected to the same normalization bias. The truly revolutionary discovery will be quietly filed away as a slight measurement error. This is the great, quiet tragedy of the 3i Atlas revision. It is not the loss of a single data point, but the subtle corruption of the institutional gaze. It affects the filters we apply to the universe. We stop looking for the truly alien and start only seeing versions of ourselves reflected back in the cosmos, objects that behave according to the established rules of our own solar system. The universe is far more imaginative than any grant proposal, and by imposing our expected order on the interstellar visitors, we lose access to that magnificent, chaotic imagination. Let us return to the three anomalies that anchor our story and connect them to this new blind spot of normalization. The volatility discrepancy, the difference between the high Nu 1 and the low Nu 2, demonstrates the ability of the system to self-correct toward the expected mean, rather than embracing the unexpected extreme. The non-announcement, the lack of transparent justification for the change, teaches the next generation of scientists that data changes can happen in the archive, undermining the trust in the permanent record of observation. And the target downgrade, the reduced urgency for a dedicated mission, sends a message that exotic discovery is less important than budgetary stability. The mythic reflection here is the story of the mapmaker's fear. In ancient times, mapmakers would often write, "Here be dragons," on the edges of their known world, not because they knew dragons were there, but because they feared the unknown. The quiet revision of the 3i Atlas data is the modern-day equivalent of the astronomer or the data custodian, quietly rubbing out the "Here be exotic ices" annotation and replacing it with the comforting label, Standard Water Comet. The fear of the unknown is quietly replaced with the illusion of certainty. This silent act of normalization is deeply rooted in the human reflection we discussed earlier. It is a desire for peace inside the scale of the cosmos. The universe is immense, indifferent, and chaotic. To maintain our sanity and our scientific focus, we try to contain its chaos in beautiful, predictive equations. The data point of Nu 1 was a challenge to the equation. The quiet insertion of Nu 2 restored the balance, but at the cost of genuine inquiry. As you listen, wherever you are tonight, feel the subtle tension between these two forces, the terrifying vastness of the universe and the small, human desire to categorize and control it. We are about to pivot away from the specifics of 3I Atlas and look at a grander scale, the great silence itself. We will ask if this kind of subtle, systemic normalization could be influencing not only our search for interstellar debris, but our far grander search for extraterrestrial intelligence. The quiet, profound, and deeply human question of whether we are truly alone. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "Sensor artifact." The unofficial whisper said, "Structure, not smooth like ice, angular, intentional." The kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3, I-Atlas, corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from high-rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. "Then don't say it out loud." 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form. Skin faintly iridescent, eyes reflecting the green-gold spectrum of 3i Atlas. Life had achieved coherence. But the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorrell stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3i, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3i Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave, certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3. I-Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo. But you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare. And somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the Sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass. Except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new. Faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together. A self-sustaining scar on the fabric of space. A wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies. No delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution, it was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest, Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it "not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity, and through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist; China, the poker-faced strategist; UAE, the cheerful intern, suddenly told not to speak; and ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did three separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty publicly is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when three space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, it's the kind that practices scales." You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3I Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3I Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums. Something old and orderly is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The Skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming. A Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its Skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity, catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something, a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looks strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, The structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another Webb was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the Webb brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The Resonant Guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Nickel emissions rise and fall every 11 point. 2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3i Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue. The physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. The final approach to our cosmic conclusion brings us to the threshold of the deep, where the vibrant data of the last few months begins to settle into the steady, rhythmic pulse of history. We have followed 3i Atlas from its discovery in the high deserts of Chile on July 1st, 2025, through its scorching perihelion in October, and passed its closest encounter with Earth on December 19th. Now, as the calendar reaches the final days of December, we arrive at the Great Silence finality. The object is currently racing away from our Sun toward the constellation of Leo, moving at a velocity that has already carried it nearly 300 million kilometers from our home planet. This is the moment where the awakening transforms into a permanent state of awareness. We are no longer a species waiting for a sign. We are a species that has received one. The silence that returns tonight is not an absence, but a presence, a heavy, thoughtful quiet that settles over the world like a blanket of fresh snow. You are drifting now in the cinematic stillness of your room, reflecting on the human meaning of this interstellar visitation. Imagine the scientists at the Green Bank Telescope and the Breakthrough Listen project, who spent the hours around December 18th scanning the traveler for even the faintest whisper of a technosignature. While they found no narrowband radio signals, no electronic hums, and no rhythmic beacons, the silence itself has become a data point of immense value. As a scientist, I find a certain dry, philosophical humor in our search for a shout in a universe that clearly prefers to speak in shadows. 3i Atlas did not need to broadcast its origin. Its existence as the third known interstellar object is a message more powerful than any radio wave. It tells us that the Great Silence is a choice of the distance, not a lack of life. The Great Silence finality is the acceptance that some neighbors prefer to pass by in the night, leaving only their footprints in the dust. The meteorologists of the cosmic dawn are currently tracking the interaction between the visitor and the massive solar active regions, numbered 4294 through 4298, which have been unleashing X-class flares into the path of the receding comet. This is the impossibility stack of the final phase. We are watching as the anti-tail of 3i Atlas, a sunward-pointing jet estimated to stretch nearly 1 million kilometers in length, interacts with the solar wind. Observations from the TTT robotic facility in Tenerife have revealed that these jets were wobbling with a period of 7 hours and 45 minutes, a rhythmic heartbeat that suggests a complex, rotating nucleus. To understand this is to understand the grounding data of a world that was born around a different star. We are seeing the internal mechanics of a stranger, a witness to a star system that may have died long before our sun was born. Think about the cosmic perspective of this departure. 3i Atlas is expected to reach its perigove, its closest point to Jupiter, on March 16th, 2026. At a distance of 53.6 million kilometers, it will graze the edge of Jupiter's Hill radius, a final gravitational handshake before it exits our system forever. The humor lies in our own frantic calculations. We have deployed every asset, from the Hubble Space Telescope to the Mars Reconnaissance Orbiter, to capture a glimpse of this visitor, yet the visitor remains stubbornly indifferent to our gaze. It is a blunt message in a bottle, as Professor Avi Loeb describes it, a relic that has been traveling the Milky Way disk for billions of years. When it began its journey, there were no humans on Earth to watch it. As it leaves behind a world that is forever changed by its passage. The Great Silence finality is the sound of a closing door that leaves us on the outside, looking in. As you settle into the soft, rhythmic darkness of your bed, let the echoes from the past act as a mental sedative. We are part of a long lineage of observers who have looked at the guest stars and wondered about their souls. The difference is that now we have the human reflection of global data. We have seen the teardrop-shaped coma captured by Hubble and the ultraviolet hydrogen halo seen by MAVEN at Mars. We have the proof that the building blocks of life, water, carbon dioxide, and complex organics are common currency in the interstellar void. The great silence finality is the realization that we are not a unique accident, but a local expression of a galactic law. The stillness in your room is a reflection of the stillness of the void. Both are full of potential. Both are waiting for the next traveler to break the peace. The historical humorist in me thinks of the way we will tell the story of 2025. We will remember it as the year of the comet, the time when 3i Atlas, Lemon, and Swan all shared our sky. But while the others were local celebrities, 3i Atlas was the traveler from the deep. There is a calm tension in our goodbye. We are losing a piece of the galaxy that we will never see again. The dry, philosophical humor of the universe is that it gives us just enough time to fall in love with a mystery before it pulls it away. But the legacy of the third visitor remains in our archives, in our textbooks, and in the dreams of every child who looked up and saw a fuzzy star in the pre-dawn sky. We have moved from the awakening to the watch. We are the sentinels on the shore, and we are no longer afraid of the dark. Imagine the what-if pivot that now defines our future. What if the wobbling jets are not just cryovolcanoes, but the rhythmic pulses of a machine? What if the geometric coincidences of its trajectory were planned? The great silence finality does not answer these questions. It provides the space for them to exist. It is a contemplative buffer. We are no longer rushing to the next headline. We are sitting with the final unresolved thought. We are learning that the universe is a house with many rooms, and we have just seen the hallway light turn on and then off again. The silence is now a sophisticated one. It is the silence of an expert, the silence of a species that has finally graduated from the local school and is looking at the university application for the galaxy. As the night wraps its cinematic velvet around you, let the great silence finality be your blanket. There is a profound peace in not having all the answers. There is a beauty in the unresolved mystery. 3i Atlas is now billions of kilometers away, heading back into the true dark. It is becoming a part of the background, a ghost in the machine of the heavens, but it has changed the way you breathe. It has changed the way you sleep. You are sleeping in a universe that is a little less quiet, a little more crowded, and infinitely more fascinating than it was when you woke up this morning. The traveler is moving toward Pegasus, and you are moving toward a new understanding of what it means to be human in a galaxy of travelers. The quiet humor of the cosmos is that it keeps us guessing. It gives us a hint, a shadow, a fleeting glimpse, and then it goes back to its enigmatic, silent self. It's like a teacher who drops a single, cryptic clue on the chalkboard and then walks out of the room, leaving the students to figure it out together. The great silence finality is our study hall. It's the time for us to talk to each other, to share our theories, and to prepare for the next lesson. And the best part is, the next lesson is already on its way, moving through the dark at 60 kilometers per second. We are ready, we are waiting, and we are no longer alone. The night is deep now, and the world is still. You can feel the weight of your body, the warmth of your room, and the immense, beautiful quiet of the universe. The story of 3i Atlas is not over. It is just being whispered now. It is being told in the data, in the books, and in the quiet wonder of people like you who are still awake to hear it. But even for the curious, it is time to rest. The silence is calling you. and it is a kind, familiar voice. It is the voice of the stars, and they are telling you that you are right where you belong. You are a witness. You are a part of the story, and the story is exactly as it should be. The final image of the traveler is a cooling core against a sea of diamonds. It is moving away, its light fading, but its impact is permanent. We have seen the third visitor. We have looked into the eyes of the deep, and in that reflection, we found our own strength. The great silence finality is the peace of a journey well watched. You can close your eyes now. The sky is in good hands. The data is saved, and the universe is still as marvelous as it was when the first human looked up and wondered. It's time to go back to sleep and dream of what lies beyond the heliopause. As we reach the end of this journey, we find ourselves standing on the quiet shore of our own reality, looking back at the long, dark trail left by 3I Atlas. We have moved from the shock of discovery to the deep reflection of the unknown, and in doing so, we have honored the endurance of our species. We are the descendants of survivors who once sat by small fires and feared the shadows, yet today we build eyes of glass to track those shadows across the light years. There is a quiet humor in our persistence. Our ancestors survived a primordial soup that might kill a modern man, just so we could one day argue about the isotopic ratios of an interstellar rock. We owe a debt of gratitude to the traveler for reminding us of our shared identity as the inhabitants of a small blue world. History bends, but it never breaks. It only stretches to include new mysteries and new neighbors. As you settle into your final rest, know that you are part of a lineage that refuses to stay in the dark. The stars are no longer distant points of light, but the origins of our newest friends. Sleep now, for the universe is wide, the night is kind, and the journey is timeless.